Okay, so good morning, dear students of IT 6208, System Integration and Architecture 1. I am Ms. Karen V. Lara, your OLC from AMA East Rizal. So welcome to our virtual class today. So last meeting, we have discussed the following concepts of system testing. Its definition, the importance and characteristics of system testing, guidelines of system testing, key areas and prerequisites of system testing, different types of system testing, tips to perform the system test, the difference between error, defect, and failure in software testing, system testing's contribution to software development. So for today's meeting, we will be discussing the following. What is system integration? Types of system integration methods, the role of system integrator, steps of system integration process, reasons why integration projects fail, what is software deployment, advantages of software deployment, the various activities of software deployment, and steps of release management process. So, for the last decade, the aggregation of different component systems or subsystems that cooperate to deliver a whole functionality has been the focus of industries that we use technology. So this is known as the modular approach to systems building, and the system integration process has always been at the near end of the development cycle. So because systems or subsystems to be integrated may span different fields in software and hardware engineering. So system integration is defined in engineering as the process of bringing together the component subsystems into one system, an aggregation of subsystems cooperating so that the system is able to deliver the overarching functionality, and ensuring that the subsystems function together as a system. And in information technology, as the process of linking together different computing systems and software applications physically or functionally to act as a coordinated whole. So system integration is like putting a puzzle together. There are scattered pieces of an organization's information subsystems that need to fit together into one well-coordinated, cohesive architecture or integrated application mesh. It is a complex building process that connects an organization's function from varying systems, streamlining disparate systems, including existing hardware, software, and communication. So, system integration is an IT or engineering process or phase concerned with joining different subsystems or components as one large system. So it is also used to add value to a system through new functionalities provided by connecting functions of different types. So these are the different types of system integration methods. So the first one is the vertical integration. So subsystems are integrated according to the functionality by creating silos of functional entities beginning with the bottom basic function upward vertical. So this very quick method only involves a few vendors and developers but become more expensive over time because to implement new functionalities, new silos must be created. So basically, in this method, each subsystem is linked to the other on the basis of how closely they are related in the function that is performed. So this method is fairly simple and involves a small number of systems. But on the other hand, the system integration model can be inflexible. So these are the advantages of vertical integration. So the first one is efficient supply chain coordination. We have streamlined vendor communication, enhanced competitiveness, greater control of processes, and lower operating costs. So example of this type is a point of sale or POS system that tracks order and record sales transaction while another software generates invoices. So this is where the term silo comes into play since the system is tightly integrated to serve a specific and narrowly defined business function, holding the data in one place without coordinating with other silos. So the second type is the horizontal integration. So it involves the creation of a unique subsystem that is meant to be the single interface between all other subsystems, ensuring that there is only one interface between any subsystem and any may be replaced with another without affecting the others by using totally different data and interfaces. So this is known as Enterprise Service Bus or ESB. So in other words, the number of connections necessary for system integration is reduced because the subsystems are not interconnected directly. They are connected indirectly through the main system. So if there are five subsystems, there will only be five connections. So the advantages are higher operational efficiency, scalability for dynamic workloads, incremental or phase approach to SI or system integration, high availability for business continuity, expand to include additional technology, and versatile communication capabilities. So the primary advantage of this method is the reduced number of connections necessary to maintain functionality, which in turn reduces time, effort, and money spent building the system. Example of horizontal integration can be found in healthcare sector in achieving a simplified method for medical system integration. The third type is the star integration, also known as spaghetti integration, because each subsystem is connected to multiple subsystems so that the diagrams of the interconnections look like a star. However, the more subsystems there are, the more connections are made and it ends up looking like spaghetti. So furthermore, when the system integration method interconnects each system to the remaining subsystems, the series of connections can look like a star polyhedron at the best of times. In other words, the ideally neat and tidy IT infrastructure quickly becomes jumbled and difficult to map if a company approaches this kind of method. So because this will provide far more functionality than the individual point-to-point connection, but the management of integrations become very demanding. So what are its advantages? So we have quick application feature implementation, deployment flexibility, simplicity. The fourth type of system integration method is the common data format. So it helps the system avoid having the adapter convert to and from every application format. Systems using this method set a common or application independent format, or they provide a service that does the transformation to or from one application into the common application. So the data format allow each system to do only one data conversion from its native format to the common or vice versa. So this way, the number of required data transformations is just as high as the number of subsystem. So its advantages are seamless data translation and automation. So example of common data format is converting zip codes to city names by merging or dividing objects from one app or database to another. So what are the different roles of a system integrator? So SI is an individual or business that brings together multiple elements such as hardware, software, networking, and storage from multiple vendors. in order to create a system for the client. It is regarded as a company that specializes in implementing, planning, coordinating, scheduling, testing, improving, and sometimes maintaining its system. So they also deliver large IT projects, example, ERP projects or enterprise resource planning, trying to manage such projects and the numerous suppliers involved. So good example of system integrator are IBM, Accenture, TCS to name a few. So the system integrator's role is normally to design, implement, and test the integration solution, but the role of the systems integrator may also include continuous management of the solutions as well as contacting third parties to enable connections with them. So the role of system integrator is narrowed down to enabling the data integrations between the different existing systems of the end customer defined in the project scope. So most importantly, the system integrator brings to the table integration expertise that the customer is otherwise lacking internally or has a shortage of available internal resources at hand. Okay, so an example of major system integrator is the Folio 3. So Folio 3 is a California-based software development company that helps entrepreneurs and large corporations build innovative, world-class software solutions by providing offshore application development and support. So they specialize in enterprise applications, mobile apps and games, websites and web-based applications, and social media platforms and applications development. The company also helps organizations worldwide to improve their processes with innovative solutions. And Folio 3 assists business with digital transformation, cloud migration, and the implementation of agile organizational structures. Okay, so boosting up the productivity and improving the workflow of the company is an essential if your goal is to succeed in a certain business. So a systems integrator is a great way to achieve those goals. So however, the development process may be long and complicated. So in order to do so, the task is usually split into six equally important phases. So what are those phases or steps of systems integration process? So the first one is requirements gathering. So I know you are very much familiar with this particular phase of the software development process. So the first step consists of one or more meeting when you share your ideas and requirements with the system integrator. It is crucial that you know exactly what you and your team expect the future system and its components to do. So in order to provide you with an efficient solution, an IT company has to come to make sure your employees and customers will find the software solution comfortable and easy to use. So in this particular step, there is no such thing as a standard system integration. So every company uses different subsystems in order to achieve different goals. It is extremely important for a system integrator to know your requirements very well. So the next step is analysis. So after expectations and specifications of your future software are listed down, business analysts conduct a thorough analysis in order to determine operational feasibility. So what do you mean by operational feasibility? So basically, operational feasibility is you are determining the doability of your software. Okay, so they are experienced in translating your requirements into needs and improving the communication between you and the development team. It allows an IT company to connect their vision of the system with yours. So this step, what you want is not always what you actually need. So listen carefully to the company you have chosen and their advices. So a successful collaboration will help them to provide you with the best solution suited to meet all your needs. Okay? So the third step of system integration process is architecture design. So through the analysis, a systems integrator is ready to perform the process of putting your subsystems together. So however, before they start, they need to build a strong foundation in order to eliminate all of the risks. So that is why the next phase is dedicated to writing a plan of how multiple components should be integrated so that they can function as a whole. So usually blueprints of the integration are created to help both sides to visualize the process. So, a system integrator aims to provide you with a solution which will boost your productivity and improve your workflow. But their main objective is to ensure seamless data connectivity between all of the components. So, a proper architecture design allows them to perform an efficient integration. So the fourth step is the systems integration design. So this is considered as the longest and the most challenging phase of the process where the actual integration is performed. So based on the architecture design, which is rather a logical design, its physical equivalent is also developed. So by the way, the logical design demonstrates the logical flow of the system or the software. So it is represented by flowcharts and other design tools that we have discussed before. So if all of the previous steps have been followed with a close attention to detail, a system integrator should perform systems integration successfully and easily without losing valuable data. So, depending on their number and size, connecting various independent systems into one while ensuring regular data flow may take some time. So, however, this phase requires great precision. A successful integration can help the company to grow by automating many business processes and providing you with accurate data. So the fifth step is implementation. So once the system is ready, it is verified and tested. So if test engineers detect any bugs, it is fixed and the system undergoes operational testing one more time. This is to ensure the product you receive is errorless. So only then your order goes live so you and your employees can start enjoying the software or system. Even though the new solution is based on your previous component, it may take to get familiar and comfortable with it. So the implementation, so this one is improving the workflow of your company. So in order to notice the results of the integration, you need to make sure everyone in the team understands exactly how the new solution works. So that's why in this particular phase, we are also conducting workshops and trainings for the end user in order for them to be familiarized with the software and system. Next is maintenance. So the competitive advantage of having your subsystems integrated by a professional company over buying a new off-the-shelf solution is that a systems integrator makes sure your product works flawlessly even after it is released. If you find it hard to use or having a missing feature, the components can be modified or added anytime. You can also report every bug to detect, and the company that has built the system for you will take care of fixing it. So as the company evolves, the system can evolve along with it. So there is no need to acquire a new product as it is much more beneficial to upgrade the system you already know and find easy to use. So before we have discussed that maintenance is a part of the software development life cycle, which is an ongoing process in the life cycle. So it is also a phase or stage wherein a Aside from correcting those errors or eliminating those errors inside the system, we are also adding new features, functionality, or components inside the system. Okay, so according to some studies, as many as 70% of all system integration projects fail to achieve the goals set for the project. So we will now be discussing the various reasons that can lead to this situation and try to provide solutions on how to avoid the most common mistakes regarding data integration projects. Okay, so the first one is oversimplifying the integration project. So the easiest way to get an integration project start off down the wrong path is to ignore the complexities involved in the processes that the integrated systems handle. So people who do not know or understand the business processes involved can very easily overlook some important details regarding the integration. Second reason, overestimating one's own capabilities. So this is a very common issue in everything we all do in business. We all tend to overestimate our own capabilities in doing stuff that we are not really that familiar with. So some companies tend to simply go out and buy integration tools with the assumption that they will be able to use them out of the box or with minimal training. Next is focusing too much technical integration. So the goal of an integration project shouldn't be just a technical solution that enables the various IT systems to exchange information between them. So when this happens, the solution design will lead to an excessive mapping exercise and the most complex integration framework that is very rigid and difficult to develop further in the future. Fourth one is lack of clear accountability. So integration projects typically have multiple stakeholders that may have various conflicting interests and requirements. So for example, sales and marketing may have entirely different integration requirements than the finance department. The poor IT department usually sits in the middle of all of this, trying to keep everyone happy without having a vested interest in the whole integration process. The fifth one is constant changes on the environment. So with complex system integration projects, the different applications that are integrated hardly ever stay the same. So constant change is more of a rule than an exception to it. Using a waterfall model to design the integration in detail is not a flexible delivery methodology, as the rapid pace of change makes the original design obsolete very quickly. An agile delivery methodology is better for it allow changes to happen instantly and dynamically throughout the project. So number six is build it and they will come assumption. So today, organizations often decide to tackle their business to business integration challenges by publishing an API so that their business partners or customers can connect with them more easily. So most cases, this will not provide the desired outcome as you are not providing a solution to the integration problem. Number seven, shortage of integration experts. So the reason for this is that technical knowledge and expertise alone is typically not enough to make the integration project a success. So you need an integration expert that also has knowledge and understanding about different business processes and guide through the complex requirements involved. Next is protectionism. So the lack of access to data in other systems. So the owners of different systems are unwilling to grant access and share data in their system with other stakeholders in the same organization. So various reasons may be fear of losing independence, fear of information transparency, and to overcome this issue, you need a strong support from the senior management of the company that can override any protectionist objectives that may arise during the project. Ninth reason is not invented here attitude. So the most typical one of this being the internal IT department. So they sometimes tends to forget their role as a support organization and it wants to act as the driver for the integration. So to avoid this is to ask the IT department to provide a detailed project and resourcing plan and ask them to commit to it. Okay? And the last one is not starting at all. So there are so many aspects to take into consideration that people start questioning the feasibility of the whole project. So in one aspect, a system and data integration project can be quite overwhelming and organizations end up doing nothing at all. A well-designed system integration project can be executed in smaller sub-projects, keeping each individual sub-project start and enabling a readjustment of their prioritization along the way. So after discussing the systems integration, so we will now proceed with the last phase of the software development life cycle, which is the software deployment. So software deployment is all of the activities that make a software system available for use. So the general deployment process consists of several interrelated activities with possible transitions between them. So these activities can occur at the producer side, or at the consumer side, or both. So because every software system is unique, the precise processes or procedures within each activity can hardly be defined. So therefore, deployment should be interpreted as a general process that has to be customized according to specific requirements or characteristics. So software deployment brings many key advantages to enterprises. So it's tasks like installing, uninstalling, and updating software applications on each computer are time consuming. So software deployment services reduces the time and make the process error-free. The software can be easily controlled and managed through deployment. So now we will proceed with the advantages of software deployment. So software deployment includes all the process required for preparing a software application to run and operate in a specific environment, whether it's, for example, you'll be using a window platform or you will be using an open source operating system or you are creating a mobile application or a web application. So it involves installation, configuration, testing, and making changes to optimize the performance of the software. So the first advantage is time consuming. So software makes for quick rollouts within hours. So the process of installation also becomes faster than native ways. So the software can be deployed quickly and there is no need of training or learning anything. Another advantage is enhanced security. So deployment can configure the roles of permission sets, which can control sensitive or mission critical group of computers. So this offers protection to the computers in the enterprise. So task groups can also be secured by maintaining roles task based permission sets. So basically permission is defined as who will be given or granted an access to the system. So third advantage is monitor user actions. So software deployment makes it easy to monitor user actions effectively. So you can gain insight into user activities around the software. So the findings can be utilized to perform historical user activity analysis. It also ensures everything is in order and the applications are not facing any problems in their operations. So the last advantage is effective software updates. So it is very used to check for updates for each installed version of any software. So you have to search for updates and then manually initiate the download. So through software deployment, accurate updates, software maintenance tasks, and uninstall can be targeted automatically. So the computers are also monitored for issues in real time. So these are the different deployment activities involved. So the first one is release. So the release activities follows from the completed development process. So it includes all the operations to prepare a system for assembly and transfer to the customer site. So therefore, it must determine the resources required to operate at the customer site and collect information for carrying out subsequent activities of deployment process. So the next activity is install and activate. So activation is the activity of starting up the executable component of software. So for simple system, it involves establishing some form of command for execution. While a complex system, it should make all the supporting systems ready to use. In a large software deployments, the working copy of the software might be installed on a production server in a production environment. So other versions of the deployed software may be installed in a test environment, development environment, and disaster recovery environment. Next is the activate. So the activation is the inverse of activation, and it refers to shutting down any executing components of a system. The activation is often required to perform other deployment activities such as a software system may need to be activated before an update can be performed, and the practice of removing infrequently used or obsolete systems from service is often referred to as application retirement or application decommissioning. Next is adopt. So the adaptation activity is also a process to modify a software system that has been previously installed. So it differs from updating in that adaptations are initiated by local events such as changing the environment of customer site, while updating is mostly started from remote software producer. Next is we have update. So the update process replaces an earlier version of all or part of a software system with a newer release. Next activity is built-in. So mechanisms for installing updates are built into some software systems. So automation of this update processes ranges from fully automatic to user-initiated and controlled. So Norton Internet Security is an example of a system with a semi-automatic method for retrieving and installing updates to both the antivirus definitions and other components of the system. So other software products provide the query mechanism for determining when updates are available. Next is the version tracking. So it helps the user find and install updates to software systems installed on PC and local networks. So we have here the web-based version tracking system. So notify the user when updates are available for software systems installed on a local system. For example, Version Tracker Pro checks software versions on a user's computer and then queries its database to see if any updates are available. So next is the local version tracking system. Notifies the user when updates are available for software systems installed on a local system. For example is software catalog stores version and other information for each software package installed on a local system. One click of a button launches a browser window to the upgrade web page for the application, including autofilling of the username and password for sites that require a login. Next is the browser-based version tracking system. So notify the user when updates are available for software packages installed on a local system. Example is WFX versions is a Firefox extension which helps the user find the current version number of any program listed on the web. So next activity is uninstall. So an installation is the inverse of installation. So it is the removal of a system that is no longer required, or you are no longer, or you will never use that particular applications or software. It also involves some reconfiguration of other software systems in order to remove the uninstalled systems files and dependencies. Next is retire. Ultimately, a software system is marked as obsolete and support by the producers is withdrawn. So it is the end of the life cycle of a software product. So retire is also a process wherein there are no more updates or no newer versions where will be released for the user to install. So this, for example of this retirement are those software or operating systems that do not have any more updates. Okay, so in the current or in the constantly moving, ever evolving world of business IT, you can't afford to push out half baked releases. So, yet, an overwhelming 75% issues are a result of changes in software and its environment. So, to prevent costly delays and keep your organization's operations running, you held to invest in a robust release management process. So the release management process oversees all the stages involved in a software release from development and testing to deployment. So release management is required anytime a new or even changes to an existing product are requested. So there are five primary steps to release management. So we have here plan release, build release, test user acceptance, prepare release, and deploy release. Okay, so we will be defining each of the steps of the release management process. So the first one is plan release. So the planning stage may be the most time intensive as this is where your entire release is structured from start to finish. A robust release plan will help your team stay on track and ensure standards and requirements are properly met. So during this stage, create a workflow that both your team and the key stakeholder can refer to throughout a release. So the workflow should explain at a glance how the whole release is staged and how each team member plays a part. So your release plan should include timelines, the delivery dates, the requirements, whether hardware or software or other technologies that will be integrated into the system, and the overall scope of the project. So, plan release is one of the most popular release management method in the system development lifecycle. It helps software developers plan, develop, maintain, and replace software system with a high degree of efficiency and quality. So the SDLC can be used in conjunction or in place of other project management processes. So the next step is the build release. So with the release plan finalized, you can start designing and building the product for release. This is the actual development of the product based on the requirements outlined in the release plan. So once all the issues that may have come up are addressed, it's time to subject the build to real world scenario testing. So this build release could take several iterations. So as the team builds out the product, it is sent to a testing environment for user acceptance. And this allows the team to identify any bugs or issues or defects that may arise in a real world environment. The third one is the user acceptance testing, which is also known as UAT. It is when the end users the product was built for get to actually use it and give feedback. This is often done as a free beta trial online or shared with a larger group of employees within the company. So the UAT is the most crucial step to release management because of the amount of data collected and fixes required in order to get the build to where it needs to be for the official launch. So in this step also, we are getting feedback from the end users or those beneficiaries of the software system. So we will determine also if the development team meets the requirements required by the end user. So usually under the user acceptance testing, they are using some criterias that are needed to test the software based on the given checklist. So say for example, they will determine if the software or system is reliable, if the system generates reports anytime, anywhere, if the system has security, if the button or the interfaces are functioning well, if the reports or the data or the output of the system generates an accurate result. So those are some of the criteria that are needed to be evaluated by the end user. So next we have prepare release. So this step is to put the finishing touches on the product, taking into account everything that was learned in UAT or user acceptance testing. So release preparation also includes a final quality review by the quality assurance or QA team. So during the review, the quality assurance team will conduct final checks to ensure the build meets the minimum acceptable standards and business requirements outlined in the release plan. So once the review is completed, the functional team will validate the findings and finalize the release for deployment. So before the build can deploy into a live environment, it must be approved by the product owner. Next is we have the deploy release. So it's time to release your product into the wilds of the live production environment. So besides simply sending the build out into production, the deployment stage also includes messaging and education of the product to both the end user and your company at large. So this is especially important for internal releases where employees using the software need to understand it to do their work efficiently and productively. So basically, during this stage, you are training and educating your end users on the different functionality of the software, from the most important module down to the least important module of your system. So during this stage, the development team should meet to assess the release performance and discuss how the deployment went. If there are some issues, it should be identified and documented for the team to address in the next iteration. Okay, so release management oversees a constantly changing process. So each release is an opportunity to refine everything from your workflow to your checklist as the team discovers what roadmap works best for what kind of launch. So again, the different steps of a release management process are plan release, we have build release, We have UAT or user acceptance release, and prepare release, and deploy release. So those are the different steps of release management process. So by the way, there are also some types of deployment processes which are also involved in the software development. So aside from the different processes, we also have the different types. So the types of deployment process depends on what particular type of software you are going to develop. Okay, so for any questions, if you have any questions or clarifications, you can send a message through the LMS chat box, or you can email me at kvdelara@amaes.edu.ph.